Okay, section 9, chapter 4. This is the last section of chapter 4, and for many students, that is, there's a sigh of relief at hearing that. So let's get started. This is the section that we try to kind of tie everything together, okay? And we're going to start by talking about some vocabulary in terms of polynomial functions. Remember, these are functions that you can graph of polynomials expressions, all right? Excuse me. So then, the following statements are equivalent. All right, let's talk about this. If c is a 0 of p of x, then c is a root of the solution. X minus c is a factor, and c is a real number. If c is a real number, then c comma 0 is an x-intercept of the graph. Okay, so that's all very math jargony. Okay, let's look at this graph here, and let's tie all this vocab together. So to the right is this graph, the graph of this function here, okay? The zeros of the function, we can figure out, now again, that is what numbers can you plug in here that will make a 0 on the right-hand side. The zeros show up graphically as x-intercepts, here, 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 and here. So those are the zeros. So x equals negative 3, negative 2, positive 1, and 2. Okay, so those are the zeros of the function. The solutions to this equation, if we take that function and if we set it equal to 0 and make it an equation that we're trying to solve, the solutions will be the same. Again, the values that make the function 0 are the zeros. What this question is asking you is what numbers can you plug in for x that will make the left-hand side 0? Well, it's going to be the same numbers. So x equals negative 3, negative 2, 1, and 2, okay? The factors then, if I know that the factors are, if I know that these are all of the zeros, then I can figure out what all the factors are. So if negative 3 is a 0, then x plus 3 has to be a factor. And if negative 2 is a 0, then x plus 2 has to be a factor. If 1 is a 0, then x minus 1 has to be a factor. And x minus 2 will also have to be a factor. And again, that's because if you plug in 2 to the function here, you have to get 0. Well, if you plug in 2 here, you'll get 0 times a bunch of stuff. Doesn't matter what it is, because 0 times anything is 0. The x-intercepts of the function, again, this is where the zeros show up graphically, is at the x-intercepts. But when I ask you for an x-intercept, and when the book does, or when anyone's talking about x-intercepts, we're talking about the points, okay? So the x-intercepts will be points. So negative 3, comma 0, negative 2, comma 0, 1, comma 0, and 2, comma 0. Okay? All right, so there we're trying to tie a bunch of vocabulary together all in one spot there. Okay, let's talk about the fundamental theorem of algebra. This theorem says the following. Every polynomial function with a degree greater than 1, so basically any interesting polynomial function, has at least one root in the set of complex numbers, either real or imaginary. Remember, we talked briefly about how the complex numbers include both the real numbers and the imaginary numbers. The fundamental theorem of algebra says if you have a polynomial function, then you will have whatever the degree is will be that number of real or imaginary solutions. Okay, so let me show you what this means. An extension of this is also a polynomial of degree n has n roots, and you can read that as n zeros. Roots and zeros are essentially the same thing. Zeros, there's no e probably, zeros, excuse me. You can even see that anyway. Sorry, so zeros and roots mean the same thing in the complex number system, okay? So if I see that it's a degree 3 polynomial, then we can figure out, oh, I didn't write down the instructions here. Well, that's fine. Okay, so we're going to use the graph to figure out how many real and imaginary solutions there are. That's what this question is supposed to have asked you. So let's graph real quick, x cubed minus 4x plus 1. And you can do this too. X cubed minus 4x plus 1. Graph it, and you can see here that there are 3 real zeros. Okay, so that one's not that interesting. The fundamental theorem of algebra says whatever the degree is, that's how many complex zeros that will be. That means real plus imaginary. Okay, so let's look at this next one. X to the 4th minus 3x cubed. So let's do this. X raised to the fourth minus 3x cubed, and then plus x squared plus 1. Okay, so that will, there are 2 real zeros there. So 2 real, and we know that there has to be 4 total. So 2 are real, the other 2 must be imaginary. Last one, x to the 5th minus x squared. So x raised to the, x raised to the 5th minus x squared plus, minus 9. If I graph that, I see that there's 1 real 0, and that must mean there's 4 imaginary zeros. And if these were all set equal to 0, what we're talking about would be 1 real solution and 4 imaginary solutions. Okay, so they'd have i's in the answers. Okay, all right. That all leads to what is really the bread and butter of this section, which is steps to solving polynomial equations. In other words, finding all roots, or is another way to put it, or given a function, finding all of the zeros. Okay, the process is really the same, because remember, there's a very close relationship between roots, zeros, and solutions. Okay, all right. So here are the steps: factor immediately if possible, graph to find the easy roots or the easy zeros, use division to divide out those roots, and then use the quadratic formula to find the rest. So this is really important. These steps right here are critical. Okay. Now, I'm going to let this video, is probably going to go a little bit longer than I'd like, because I want to do all 4 of these problems and show them out. So if you want to split how you watch this video, then you're more than welcome to do that. But you should, as we get going here, like after I do 1 or 2, you should try them, see how you, and then play the video and see how you do. So let's get started. What I'm trying to do is solve this, and then I'll state the number and type of roots, but we'll solve first. First step, factor immediately if possible. So I notice here that I can factor an x out of the left-hand side. So I'm going to take this x out, and I'll be left with x squared plus 25 is equal to 0. Okay? And I can graph this if I want, but x squared plus 25, that doesn't factor. Okay? So once this thing is completely factored, I'm going to set each piece equal to 0. So I'll get x equals 0. Well, that was easy to solve. So that's one solution. And then when is x squared plus 25 equal to 0? Well, if I subtract 25 over to the right, I get x squared equals negative 25. And then square root, plus or minus. And so I get x equals, now this is the square root of negative 25. If we are including negative or imaginary solutions, then that's fine. The square root of 25 is 5, and the square root of a negative is I. So my answer will be plus or minus 5i. Okay? So all of my solutions then are 0, and then plus or minus 5i. So if I'm to categorize these, there's 1 real and 2 imaginary. Okay? Sorry, that's poor handwriting there, but you heard me say it. So, and by the way, that's 3 total solutions, which is what we would expect given a degree 3 polynomial. Okay? Solve and state the number and types of roots. Okay, how are we doing on time here? Okay, we're doing okay. All right, solve and state the number of types of roots. So I follow the same steps. Factor immediately if possible. Now, this one turns out to be a difference of squares. You can break this into x squared. You can write it like this: x squared squared minus 16, which is 4 squared. So 16 would be x minus 4 squared. But let's say you don't notice that, right? Let's say that you don't realize that that's a pattern that you could factor right away. What you can do is take your graphing calculator out, graph it. So let's say you missed that step 1 is applicable. You go to step 2, graph to find the easy roots, and you see that, oh hey, negative 2 and 2 are solutions, are zeros of the function. So what you can do then is immediately factor out the easy roots. Okay, so this is on to step 3 here, where we're going to use division to divide out the easy roots. The easy roots are integer roots, numbers like negative 7, negative 5, negative 2, 0, 1, 8, 3. Those are integers, right? So I'm going to take negative 2. I'm going to divide that out first. Okay, so negative 2, and then I got to be careful though. It's 4th power, and so there's a 1 in front of the 4th power, but there's no cubed term. There's no second power term. There's no 1 power term. So I have to have zeros to represent all of those, or as placeholders. And then negative 16 for the last one. So I'm going to bring down the 1. Negative 2 times 1 is negative 2. Add them up, negative 2. Negative 2 times negative 2 is 4. Add them up, it's 4. Negative 2 times 4 is negative 8. Negative 8. Negative 2 times negative 8 is positive 16. Add them up, that's 0. And then I'm going to do it again. Now, when you're doing multiples, so like we did negative 2, now I'm going to go do 2. I don't need to rewrite everything. I'll just leave it right there, and I'll put the box, and then we'll go again. So bring down the 1. 2 times 1 is 2. 0. 2 times 0 is 0. Add them up, that's 4. 2 times 4 is 8. Add them up, that's 0. And so now we need to analyze where I'm at here, okay? So I started off as a 4th power polynomial. I did division once, so that'd be a cubic, 3rd power. I did it again, that'd be a 2nd power then. So this would be x squared plus 4. So if I was to stop right here, this is the equation that I would have. X squared plus 4 times x plus 2 times x minus 2 equals 0. Okay? I can set each piece equal to 0 and solve. If I set this equal to 0, it's negative 2. If I set this equal to 0, it's positive 2. If I set this equal to 0, well, I better go figure that out. Okay, so I didn't leave much space. I apologize. I had more space on the back. Bad thinking here. But if I set x squared plus 4 equal to 0, subtract 4 from both sides, I get x squared equals negative 4. Square root. So your answer will be x equals plus or minus 2i. Okay, so finally, all of our solutions then are x equals plus or minus 2i and x equals plus or minus 2. That's 4 solutions, which should make sense with a degree 4 polynomial. Okay, so let's, I think that's all I wanted to say about that. So again, we just followed the steps. Factor if possible, we didn't think it was. So we graphed it, found the easy roots. Then we used division to divide them out, so right here. And then we didn't need the quadratic formula. It turned out we could just solve this using algebraic techniques. All right, now I know I said I was just gonna let this video go long. I'm gonna actually stop the video here. I'm gonna make a second part, which will go over 3 and 4. You are going to wanna watch that as well. That's why we're taking 2 days on this section, so you've got time to kind of watch and digest each video and do some problems along with it. So I'm gonna pause, or I'm gonna stop the video now, make a second part, and then we'll finally be done with chapter 4.